Hi there. In section 1.2, we will be talking about the commutative, the associative, and the distributive laws. The first thing we have to look at is what are equivalent expressions. These are going to be expressions that represent the same value. Let's look at an example of two expressions that would be considered equivalent. So for example, if we have the expression 4 times x, and then I rewrite this expression as x times 4. Regardless of what value we substitute in for x, these would be considered equivalent expressions. So these two things would be equal to one another. Let's first look at the commutative laws. The commutative laws state that changing the order of addition does not affect the answer. Looking at an example of what that might look like. If we have 3 plus 2 times an x plus a 7. If I were to write this in a different order to add these things together, it would make it easier to simplify when we get to that part of this course. So for example, I could rewrite this as 2x plus 3 plus 7. The 3 and the 7 are both constant terms, so by writing them next to each other, I could then add those two things together very easily to get 10, and then we'd have 2x plus 10. That's the commutative law of addition, when we change the order of the things being added. Here it starts with a 3, then a 2x, then a 7. And on the right-hand side of the equal sign, we started with the 2x, then the 3, then the 7. Let's look at the next one. The commutative laws for multiplication. Changing the order of multiplication does not affect the answer. Using what we looked at previously under the example for equivalent expressions, this would actually be an example of the commutative law of multiplication. Because if we have 4 times some number x, that is going to be equivalent to taking that same number of x and multiplying it by 4. When we change the order of the factors being multiplied, we will always get the same answer. So example 1 says use the commutative law of addition. So we have to use the commutative law of addition to write an equivalent expression to 7 plus AB. So we start with 7 plus AB. We have to ask ourselves, what are the two things being added here? Well, we have a 7 being added to an A plus B. So all we have to do is rewrite that using the different order, meaning we're going to have the AB first, and then we add the 7. Good. Example 2, use the commutative law of multiplication to write an equivalent expression to 7 plus AB. Notice how we are starting with the same expression, but now we have to use the commutative law of multiplication. So we ask ourselves, what are the things being multiplied here? Well, we have an A times a B. So that's what we have to change the order of. We have to be careful to leave the 7 and the plus where they were. We do not want to apply the commutative law of addition if it's not asking us to. But instead of A times B, we need to write it as B times A. Those are the commutative laws. A way you can help remember what the commutative law is think commutative starts with CO. Think of that representing of change order. So the commutative law is when we change the order of what's being added or multiplied. The commutative law does not apply to subtraction, nor does it apply to a division. Because it's coming up here in the top to write some scratch work. If I have any two numbers, let's say 6 and 7, if I take 6 minus 7, I'm left with a negative 1. If I change the order and rewrite it as 7 minus 6, I'm getting a positive 1. We know that negative 1 is not equal to positive 1, so therefore we have just proved that subtraction is not commutative. Okay, the next law we're going to look at is the associative laws. The associative law says that numbers can be grouped in any order for addition. Let's use an example similar to what we looked at previously. If I have 2x plus 3 plus 7, and I have the 2x and the 3 grouped together, that's not as helpful because we can't add a 2x and a 3 because one has a variable, one does not. But what we can do is let this be equal to an equivalent expression and change what's being grouped together. Here I'm going to let the order still be the 2x plus the 3 plus the 7. Notice how the order of the 3 terms does not change, but what we are going to change this time, instead of grouping the 2x and 3, we're going to group the 3 and 7 because we can add a 3 and 7. So by changing the grouping, we can simplify this problem easier. The next one. The associative law for multiplication. Numbers can be grouped in any order for multiplication. We looked at an example very similar to this on the first day of class. If we have 1/2 times 3 times 2, and I group the 1/2 times the 3, we have to complete that operation first. But if we take 1/2 times 3, we're getting a decimal, and then we'd have to multiply that by a 2, which might not be as easy. But if we use those same 3 factors in the same order, 1/2 times 3 times 2, but we group it slightly differently by grouping the 3 and 2. Now we say 3 times 2 is 6, half is 6, we find is 3. It's a lot easier to simplify by changing what's being grouped. Notice how we're really paying close attention to what is inside the parentheses. We're changing what's inside the parentheses here. Example 3, use the associative law of addition to write an equivalent expression, then simplify. So we have this x plus 7 plus 3. We have to first start by writing an equivalent expression by using the associative law of addition. Well, since we have x, then a 7, then a 3, we have to start with x plus 7, then a 3. We do not want to change the order here. In the example that's being given, or the original problem, the x and the 7 are being grouped, so we have to change that and we can group the 7 and the 3. Just like we talked about earlier, what is 7 plus 3? Right, that's a 10. So we can simplify this and leave it as x plus 10. We cannot add the x and 10 together because one has an x, one does not, so we leave it as x plus 10. Okay, next page. The last law we're talking about is going to be the distributive law, and we're also going to talk about the process of factoring as well. The distributive law relates expressions such as 5 times the quantity x plus 2 and 5x plus 10, which uses addition and multiplication. We have 2 vocab words in this course, and you'll see these in this course and your future math classes, called factors and terms. These were on the reading from the previous lab. Factors are parts of a product, whereas terms are parts of a sum. Oops. So looking at factors, this first expression that was written, 5 times the quantity x plus 2, shows us an expression using factors or multiplication. When we read it, we read 5 times x plus 2. So when I write that 5 times x plus 2, notice I wrote the multiplication sign in there. That might be helpful to identify the factors. If we have to list the factors of this expression, we want to ask ourselves, what are the things being multiplied together? Well, we have a 5 being multiplied by an x plus 2. Therefore, the factors of this expression are 5 and x plus 2. We can do the same thing for this second expression of 5x plus 10. If we have to list the terms of this expression, we want to ask ourselves, what are the things being added? Well, we have a 5x and a 10 being added together, so those would be the terms. Example 4, list the terms in the given expression. Well, terms are things being added, so the 3 things we're adding here would be the 3s, the st, and this whole last term as well. So if we have to list the terms, we'd have a 3s, we'd have an st, and lastly, we'd have a 2s over t. We'd have three things because they are all being added together. Example 5, using the expression from the above example, is 2 a term or a factor? So we're looking at just this 2. We know that 2s over t, the whole thing, is a term, but within this, the 2 itself, right, that would be a factor. So 2 is a factor, and we can think, okay, so why is it a factor? Because it's being multiplied by the s. If this expression were 3s plus st plus 2, then in a case like this, the 2, that would just be a term because it's not being multiplied by anything. So what we can do then in example 6 is we can use the distributive law to multiply. So we're going to take this expression written using factors and rewrite it as an expression using terms. The idea is we have to take this 6 to distribute it, and we have to multiply it by the m, we have to multiply it by the 2, and we have to multiply it by the 5n. So I'm going to start by putting my equal sign, and I have to take my 6, just like we said, and multiply it by the m, bring down the addition, we have to take the 6 and multiply it by the 2, again, bring down the addition, and then take the 6 and multiply it by the 5n. We are distributing the 6 to each term inside the parentheses. Then we have to simplify. 6 times m is just 6m. 6 times 2 is 12. 6 times 5n, well, we start with the number part. 6 times 5 is 30. Bring down the n. We have something with an m, something with an n, and a constant term. None of those are what we consider like terms, so we cannot simplify any further. Go ahead and pause the video and try letter B. Here we have to distribute the 5 to the r and the 5 to the 4. So 5 times r is 5r, 5 times 4 is 20. Now maybe you looked at it and did the 5 times 4 first. That's okay. You could have also had 20 plus 5r. So this note right here, when we distribute, what happens to the parentheses? So here we have parentheses, we distributed, and we get this result. Here we have parentheses, we distributed, we get this result. So what happens? Right, they go away, or we can say they are eliminated. This is going to be extremely helpful as we work through this class because when we simplify expressions, we always have to get rid of parentheses. If we can't simplify inside, we have to distribute. Just to show you what that looks like, meaning if we have 3 times 2 plus 6 versus 3 times x plus 6. Well, in the first one, since we can complete the operation of 2 plus 6, that would be the same thing as 3 times 8, 6 plus 2 is 8, and then 3 times 8 would be 24. Whereas in the second one, since we have a variable, we cannot add an x and 6. So the only way to get rid of the parentheses here would be by distributing, so this would be 3x plus 18. So if you can complete the operation, you want to do that and then multiply by the 3. If you cannot, you have to distribute, but either way, you have to get rid of parentheses. Now, lastly, we are going to, in example 7, use the distributive law to factor. All we're doing is taking something that looks like our answers previously and now putting them in their original form. We are simply undoing the process we just did. So what we have to do is look at the 3x and the 9y and say, okay, what goes into both of those? And you might say, oh, a 3 does. Right, because 3 goes into 3 evenly, 3 also goes into 9 evenly. So we start by taking 3 times something plus 3 times something else. Notice how this step here is going to look the same as this step up here. We just now have to figure out what are going to be those other factors with the 3. So we ask ourselves, 3 times what gives us 3x? That would be a 1x. Now, if we have an x with a 1 in front of it, we don't have to write the 1. We can simply just write the x, because 1 times x is x. And then we have to ask ourselves, 3 times what is 9y? 3 times 3y would give us 9y. Again, looking at the previous problem, since we have 6's here, that's what goes on the outside of the parentheses. We say we can factor out this 3, and on the inside of the parentheses are those other factors, which would be x plus 3y. That would be our final answer. We could check this by distributing 3 times x is 3x, 3 times 3y is 9y. Now pause the video and try letter B. Before we jump right to the answer, let's make sure you're on the right track. When we look at these three terms, we have to ask ourselves what goes into a 14, a 21, and a 7 evenly. Right, and that would be a 7. If you don't like how I wrote this out over here, try a different method to it. Here I wrote my 14J, my 21K, and my 7. We said that a 7 goes into all of them, so I know 7 times something has to give me 14J, 7 times something has to give me 21K, and 7 times something has to give me 7. Now we can fill in those boxes. 7 times what is 14J? That would be 7 times 2J. 7 times what is 21K? That would be 7 times, good, 3K. And lastly, 7 times what is 7? That would just be a 1. Now, previously, we didn't have to write the 1 because it was with a variable. Here we do not have a variable, therefore we have to write that. Since they all have a 7 in common, that means we have to factor out that 7, and that goes in front of the parentheses, and then everything else goes inside. So we'd have a 2J plus 3K, and lastly, plus 1. That would be our final result, and you could distribute to check your answer. That's all we have for section 1.2, so please reach out if you have any questions, and good luck on the homework.